Really excited for Jason again. Jason's accolades are here. Personally, um, known Jason since the beginning of March of this year, February, March of this year. Second SaltStack certified engineer, knows his stuff. Here at Upsite, they have a very, very cool instance of salt. Um, if Jason wants to get into that, that'd be awesome. But prolific use of SaltStack. Okay, with that, Jason.
Okay, cool. It's good to see some new faces. Just quick show of hands, who was not here last time? I think it's most people. Yeah. Okay. So the talk I was going to give tonight is kind of a part 2 of how to test salt states. So I think I'll run through my slides real quick from last time, just give a brief review, just so everybody kind of knows what we're talking about. So yeah, this is all me. It's about Upsite, which is where we are. We do analytics and marketing and segmentation tools, mostly for mobile apps. We do a lot of traffic. This is the highest traffic place I've ever worked at. Probably like 200,000 hits per second on our API, something like that. We use a lot of salt. We have some older stuff that's in Chef that we're moving over to salt because everything's easier once we get it saltified. That's not really relevant. So real briefly, what we're talking about tonight is testing your salt states. I think this is something that people should do a lot more of. Like if infrastructure is code and code should be tested, then we should be testing our infrastructure, right? On top of that, it helps us do all these things. Helps us find errors, prevent regressions. One big thing I think is it allows sort of less system-y, less DevOps type folks to contribute. Like if you have some engineers who maybe don't know a lot about systems, but they want to get in, trying their own salt states. It's really nice to have some tests. And documentation, that's another big one. Your tests can serve as documentation, just like they do with other code. Lots of things we can test. I think this basic syntax or linting is probably the #1 thing people ask for. There's not really like a great solution to this as of yet. I mentioned it last time, but if anybody here wants to do a project to make a salt state linter, like that would be awesome. I think a lot of people would really like it and use it. But yeah, we also want to test like that states are doing what they're supposed to be doing. The next level up, we want to test the relationships or integration between states. If you're running multiple operating systems, you're probably going to want to run some tests about that. So test all the things. Basics about tests. They got to run quickly. If your test suite takes forever to run, you're not going to run it, or it just really kills your productivity. Tests should always be isolated. You got to make sure that you know what you're testing. So your test should only test a very small segment of your total infrastructure. These terms on the bottom, these are what you see in like software development when they start talking about test-driven development. These are types of tests that you see a lot. It's a little less relevant when we're talking about testing infrastructure and like these high-level constructs like states. But they're good things to keep in mind that there are these different levels of testing that we want to do. So all this slide is saying is that this is the absolute minimal testing you should be doing. Before you run a high state on your infrastructure, put that test equals true flag on, just so you know what's going on. You can also do the same thing by calling states individually, right? If you use the state.sls call and use test equals true, then you'll get this nice test output without actually changing anything. Oh, right, okay, that's what I was saying here. So this is the best way I've found to test basic syntax with Salt. Well, one of the issues with testing the syntax of your SLS files, your state files, is that Salt is really flexible, right? Like, the default is to use this YAML plus Jinja construct for SLS files. But you could do JSON plus Mako, or you could do straight Python code. Or you could invent your own state renderers, right? So it's really hard, and I think this is why there isn't like a good linting package out there, is because it's just kind of a complex problem to get all those edges. But fortunately, Salt, of course, can handle all these renderers, because it's one of the features. So I think this is sort of the best way to test syntax of your states for the moment. You can either just run the state with test equals true, see if you get an error, or you can use this state.showSLS call, right? This is a good one. I think a lot of people don't know about this. And what it does is it will show you, well, so here's the same state, right, run both ways. This is just like calling the state with test equals true, and you see you get this error message that's just data failed to compile, does not render to a dictionary. So that's not great. If you use this show SLS, then you get a somewhat better error message. It's the same thing, does not render to a dictionary, but then the second line, it has a little bit more detail that's saying this file managed state that we had for foo.txt is not formatted. So that's the one you want to zero in on. So it's helpful. When it runs correctly, it'll give you a data structure that's something like this. And this is pretty close to what Salt is using internally. This is like I always forget if this is the high state or the low state data structure. I don't know, either of you guys. Yeah, I think it is the low state. So yeah, this low state data structure, it's basically just a dict associative array that has all these things that Salt cares about. So if you can get one of these out, running this show SLS, then your syntax is good, right? Your semantics might be wrong. It might not be doing what you think it's doing, but at least the basic syntax is rendering. Oh yeah, one more tip. Don't forget about outputters in Salt. Salt has the ability to change how it produces output to the shell. For running automated testing, which is what we're really going to be talking about tonight, the JSON one is pretty handy because it's easy to parse. Testing in isolation, it's all pretty clear, I think. We want to make sure that each test stands alone. It's not influenced by previous test runs. This is a lot easier in the software world. Like if you're writing code, I think that there's a lot of tools to deal with this. There's not much for testing infrastructure, so we're going to have to build it ourselves. I think the real winner solution to this is to virtualize. Containers are great. They're fast to spin up. You can, fire up a new container, run some stuff, test that it worked, and then tear it down, and then do it again 100 times, right? Unfortunately, it's not really going to work for everything. There are going to be some instances where you're going to want to use a full VM. So actually tonight, I'm going to talk about Docker. And then if this is interesting to people and we want to continue on it, then next time I'm going to go into VMs in more detail. Pros and cons, we don't really need to go through this. Yeah, I'll go through all this Docker stuff in more detail. Once we get these containers up and running our tests, then the thing we're going to want to do is automate everything. And when I think about this problem, I think there's kind of two levels of it. There's stuff that runs on the actual host, right, that handles starting and stopping your containers, determining what tests to run. If you want to test different OS versions, all that sort of thing, that all kind of runs on the host. And then on the container side, you want to be able to run tests within the container, just because it's easier to not have to deal with these layers of like transferring output and reanalyzing them. We'll go into all this. And part 2, that's where we are. Okay, so there's our quick run through on this stuff. And I saw that really is pizza. So let's take a quick break, grab some pizza, and we'll start with the actual talk.
Yep. The question maybe before we get started on part 2 is like 30, 60-second, like what is SaltStack to you outside? There's a lot of public advice. Just see if we're just
Sure.
in general, but what is there's guys doing what Salt is?
So I used Puppet a lot back in the day, several years ago. I think the biggest difference between the two is that Salt is really a remote execution framework. It's sort of configuration management is really more of a secondary feature that's built on top of the remote execution framework. And that might seem like kind of a small distinction, but it allows me to do a lot sort of fancier stuff with Salt, because I can do stuff like either just imperatively, like I can run arbitrary executable code on a bunch of machines at once. And I can do stuff declaratively with the YAML SLS files. Architecturally, it's also pretty different. I haven't really stayed abreast of what the new version of Puppet looks like, but one of the reasons I first started using Salt was because I really like the way the architecture is laid out, in that everything is based around this 0MQ message queue, right? It's the primary method of communication between your Salt master and your minions, and it's really nice because it scales really well, and then the new message transport that they just built should scale even better, the rate thing. It presents a lot of flexibility, so you can run in a sort of traditional server client mode where you have one server that's controlling all these clients, or you can run just directly on the client without having any sort of server. I think in terms of comparing it to Ansible, I think the big strength with Ansible is that it has that SSH transport, which is both a strength and a weakness, and that SSH is not going to scale to anywhere near the level that you can get with Salt and message queues. But Salt also has an SSH transport. It's sort of a newer feature. It's been about a year, 2 years, maybe a year and a half. But that's also great because if you have any nodes that you don't want to install any software on, you can run your same states and just use this SSH transport, and it'll just it makes this little bundle of files with all the Python libraries you need, and just uploads it, puts in the temp directory, runs it, and you can delete it if you want. And the other thing that really sets Salt apart, I think, is again, as a consequence of this architecture, it's really easy to do event-driven stuff, which is something I'm super into. Those of you who don't know, Salt has a component called Reactor, which lets you watch the message bus for sort of arbitrary events, and then fire off arbitrary code when it sees events. It's super cool. That's something I'm really into. It's one of my favorites. I'd like to use it a lot more in my sort of day-to-day. It's really just been something I play with a lot. If you go to the Salt YouTube channel, there's at least 2 talks that I know of about event-driven infrastructure from last year's SaltConf. There's a panel that Keith moderated, and then there's the sort of independent talk that I gave. So if you want to learn more about that, I think it's really cool stuff. But yeah, that's the overview for me. I think Salt is a lot more powerful than any of the straight configuration management systems out there. I think the biggest downside is that even though the Salt community is huge, there still seems to like not be a lot of mind share among DevOps folks about using Salt. Personally, I think that's going to change. I've kind of hitched my wagon to this horse, and I think it's a good bet. I think that I think what we're seeing with Salt is it's really the first of sort of the next generation of infrastructure management software, and it's a little bit too cutting edge. It's like people don't really understand what benefit they're getting out of making that switch. For people who are new to Salt, if you go to the meetup.com page, I don't know exactly, there's like a link for files somewhere in there. I think you have to hit like other or more or something like that. But there are slides from the first meeting we had where I went through all of the different modular subsystems. And I think that's probably like a really good place for people to start if you're new to Salt, because it's one of the things that's really confusing is there's all these sort of overloaded terms that are sort of puns based on Salt. And it gets confusing for people to kind of keep it all straight in your head. So those slides are really nice because they have just this kind of bullet pointed, here's what this does and here's where you use it. Here's what this does and here's where you use it. So yeah, check that stuff out. Okay, so for this talk, I didn't actually make any slides. I just wrote some code. And we're just going to kind of run through the code, and I don't know. I don't claim to be a guru on test-driven development or behavior-driven development, so this might be the wrong way to do it. I don't know. This is kind of just like proof of concept code. I'm going to get all this, add a couple of comments this weekend. I'll get it up into GitHub. And hopefully people will want to contribute to it. Basically, I wrote a couple of test runners. I wrote some behavior specifications. We'll go through all this. So I guess a quick show of hands, who knows what behavior-driven development is? Okay, that's most of you. So the concept with behavior-driven development is that you write natural language descriptions of features that you want to test and scenarios that you want to test. And sort of the original idea was that you could have business users and like business stakeholders write these sorts of feature specifications. And then you hand these documents over to a programmer and they would implement the code that fulfills these features. I think that's a little bit of a losing battle. Like it's not, the reason I like this style of testing is that it gives you some really good documentation if you spend some time and do it right. And the other thing I really like about using behavioral testing for this sort of application, for this infrastructure testing, is that the actual implementation, the way you write the tests, is really flexible. And we'll get into that, when you look at the actual code. So the biggest name in this space is Cucumber. It's a Ruby framework for doing this style of testing. And I'm a Python guy. I'm using Python behave for this. I'm not going to sit there and write a bunch of Ruby code, sorry. But the feature spec syntax is pretty much identical. The way this works is there's a few keywords, and they're pretty much highlighted in orange here in my IDE. So a feature is sort of the coarse-grained thing that we're testing, and that feature can have multiple scenarios. This is intended, like in the software world, they would say you had a shopping cart, right? Your feature would be like shopping cart. Then you'd have a scenario to cover all of your edges of your shopping cart code, right? Like when somebody adds an item to the shopping cart, then it shows up in the database. When somebody deletes an item from the shopping cart, then it's out of the database, whatever, right? If somebody tries to add something that's not in stock, it says it's not in stock. Each of those individual things would be a scenario. Inside the scenarios, there's pretty much 3 keywords: given, when, and then. Given is for setting up initial state, right? This is for running like setup code that you're going to use throughout the rest of your test. When represents the condition that you care about. This is typically a user action, right? Like when the user clicks buy now, then the items move to the shopping cart. And obviously then is the part that's the actual thing we care about, the result that we're testing. You'll see there's a couple of lines of and in here. The way the ands work is it just, like, it's the same as the keyword above it. So this is when I start the Docker container and when I parse the container output, then the output should be JSON, and then the output should be a dict, and the salt output should contain SLS, blah, blah, blah. Right, so this is just a way that we can split our tests into smaller segments, smaller parts. Makes them a little more reusable down the line. That's all the and is. So, again, some of you probably already know this, some of you might have guessed, but each line in this represents a piece of code, like a function, right? And I'll show you that now just so we're all on the same page. Actually, it'll be super cool and have both. Okay, again, so this is using the Python behave framework. I really like it. It's good. Check it out. Gives you some decorators that correspond to each of these keywords. So like there's a given decorator, and then all you have to do is use this decorator and put the same text that you put in your feature spec, right? So same thing. Given I build a Docker container to validate the state name. This thing in the curly brackets means that it's a parameter that I'm going to use in the function. And you can see when we look down at the function, there's a value for state name, right? And you can see if we go back here, that corresponds to the state I called test with great originality. It gives you a sort of global context, which is handy, you know, for attaching stuff to. And let's see, is there anything else I want to talk about at this right now? So is this all clear to everybody? So I want to skip over real quick and talk about Docker for just a second. So Docker. Okay, again, show of hands. Everybody heard of Docker? Yeah, okay. So you know what it is. In my opinion, the best way to use Docker is to use these Docker files, right? And I assume most people have at least glanced at these before if you know what Docker is. Basically, you give it a set of instructions for building a Docker image. And then once you've got that image built up, you can make as many copies of them as you want. You know, it's called creating a container versus the image is the sort of read-only version. One thing in this, well, a couple of things I want to point out. One thing, you can mount volumes, right? So you can have folders on your Docker container that correspond to, say, folders on your host. And this is something I think probably people are less familiar with, is this concept of an entry point. Maybe I'm wrong. Does everybody know what an entry point is? Yeah, okay. So the entry point is the first command that's run by the Docker container when you start it up. The default is bash, right? This is like every Docker container has an entry point, but most people just never see it because it defaults to bash, and that's generally what you want to do. Then the command, strangely enough, is the parameter that's given to the entry point program, right? So again, in typical usage, your entry point is bin bash, and then whatever command you actually want to run is passed to bash, right? Make sense? So that's why what you type in CMD in your Docker file is always what gets run. But we can override this, right? We can make a custom entry point script. And this is pretty handy when you know that you're going to be doing like sort of a fixed number of operations on your Docker container. Then you can have this like bash script or a Python script. I didn't get the Python script version of this done, unfortunately, but I'll show you the bash script. It's easy. So this is the entry point script that I wrote. Real simple, short bash, right? And basically, I just wrote this script so that I have a couple of sort of magic commands, right? If I want to run that state.showSLS function with JSON output, all I have to do is give my Docker container the command showSLS followed by a state name. I don't actually use the apply high state anywhere in here. That's why I didn't actually bother to write the function. The apply state, I use it in later slides. Yeah, this is the only reason to do this. But I think it's super handy. It's worth looking into. This is the type of thing that can save you a lot of time with Docker. It can really constrain your environment, right? Like if you want to do any sort of weird logging or like restrictions on what commands can be run on a particular container, like this is a sweet way to do it. So back to our Docker file real quick. Don't need this line. So all I'm doing in this is installing Salt, right? These are pretty typical. Anybody who's ever installed Salt on Ubuntu should recognize this stuff. One thing to point out, I'm only installing the Salt minion. We're going to run all these tests in a masterless mode. So all you need is the minion, and you just copy the states over. I have volumes represent the etc salt directory for the config, just because I like that. It's a little easier to poke at the config. One of the things I wanted to do for this talk, but I didn't quite get it done in time, was add some capability for like changing grains on your host, like within your tests. Like say I want to run this test with this set of grains. And I want to run that test with that set of grains. So that's part of why I had the config directory as a volume. And then this directory is where we're going to put our states and pillar. Although, again, I'm not really using pillar in any of this, but in the future, that's where it'll go. In case I didn't make this clear, this is totally like a code project I'm developing further. This is just like the alpha code. It will be on GitHub. This is stuff I really want to use, so I'm going to keep working on it and making it better. So, okay, Docker file, Docker, stuff clear? Cool. Okay. So let's get down into some real stuff here. So here's my first pass at a feature spec. As it says, the feature I'm going for here is that SLS files all have valid syntax. This is sort of, this little phrasing up here, that's sort of a behavioral driven development style thing, is that they always want to put, in order to do X, as a type of person that I am, like as a user or as a DevOps, I want to be sure that I can do Y. So I just typed it for fun. It doesn't really matter. Again, this is just sort of documentation. It's not really super relevant for any of the stuff we're testing today, but I just want to get it out there so everybody knows. And then here's our scenario, which is actually going to do the syntax testing, right? So what we're saying here is that we want to run tests on a state called test. Sorry, I should have given it a better name. And make sure it has a valid syntax. The upfront work that we want to do, like setting up this initial environment, the given clause, is we're going to build up a Docker container to validate that state. Then when we start the Docker container and parse its output, then we want to make sure the output we get back is JSON. The output should be a dict. And the output should contain this little blob of text, right? Because this is just a thing I found that every valid rendered SLS file, if you use this the show state function that I was talking about before, it will always tell you the SLS and then the name. A next step on this would be parameterizing it more, right? Like you don't actually have to write a scenario for every state. Again, I just didn't have time to finish my discovery suite. I started working on it, but it's not ready, so I didn't want to show it. So these things in quotes, I would actually use, maybe a table of states or maybe a little piece of code that's going to go through and look at all your states and just run this on all of them because we always want valid syntax, right? And that's kind of the thing to keep in mind with all of this is even though I'm showing a couple of like single use cases, all of this could be scaled up to be automated with lots and lots of states. Okay. So behave lets us have this environment code where you can do like before and after, like setup teardown type stuff. So I use that functionality to do some of the initial Docker stuff. I'm using a library called DockerPy that is just an API to Docker because I don't want to sit there and either write out a bunch of bash scripts or have to type a bunch of sub-process code. So run this on a Mac. So you need to do a couple of fancy things to get boot to Docker to work. Basically, it's just turning off TLS. This function here is just a wrapper around the DockerPy create container method. And basically, it sets up like where the volume mount points are. This would be where you added any port mappings that you want to do, which is another thing that is on my short list to add. This.
Are you guys using Docker in production right now?
Yeah. I use this before feature construct means that this is code that will run every time before a feature. There's also an after feature construct. I couldn't get to do what I wanted. It was kind of frustrating me, so I just got rid of it. Okay, so back to the step implementation. I guess one thing I should point out when you're structuring your code for Python Behave, what it wants is a directory called features, where you have files that are like .feature, like whatever you're calling it, .feature, and a directory called steps. And in that directory is where you put your Python files that actually implement all the tests that you're going to run. So I'm not going to like go through this line by line because I'm going to post the code, but I want to make sure everybody's following. So again, we have this given construct. So anytime we have a feature file that calls this text, right? And you can use regular expressions. You can make it fancier. And it's going to run the code in this function. So all this does is much like it says, it builds up a Docker container, right? Builds it, doesn't start it. I need to have something like this because I want to tell it what command to run, right? What function out of that entry point script I want to do, and what the name of the state is, because that's a parameter that I'm going to pass to that entry point script. That pop-up does. And here's the first action, right? When somebody starts this container, which, of course, the code is actually starting the container. It's the automation part. Then it's going to try to parse the container output. And this is where it gets a little wonky, honestly. This took me a while to kind of massage. Basically, I'm pulling... Docker likes to output everything just to standard out. There's also a functionality to pull to replay all of that, like the Docker logs functionality. So what I'm doing here is on that container where I installed Salt, and it has all the states, right? When I start up the container, that entry point script is going to automatically run that command. It's going to run the state.showSLS, and it's going to give me a chunk of output. And what I want to do here is take that output and parse it into something I can actually work with, like something where I can test it, right, and make sure that it's saying what I want it to say. So basically, again, you can look at the code later, but this is how you do it, is you got to grab all the Docker logs, and it's like a streaming thing, so you got to do this little loop. This is a list comprehension. And it has too many new line characters in it, so I did a little new line strip. And then I rejoin it with a single new line, because what I'm actually going to want to do is parse that as JSON, right? Again, I'm using that JSON outputter. But I want it to be clean JSON, otherwise it just doesn't work. I'm putting all this stuff on the context variable, that global, because I'm going to use it later on down here. There's no real good way to pass parameters between these functions. You kind of have to use the context, right? That's sort of your global state for this test run. And it gets wiped out between tests, so it's pretty safe to do. And then this right here, this is the part that really annoys me. This is what I was trying to do in the after feature, which is just stopping the Docker container and then deleting it. But I could not for the life of me. I couldn't figure out how to pass context back from this to the after feature thing, even though it has a context variable. It doesn't seem to be the same. And like I said, I got frustrated and didn't want to dig into it. There's a better way to do this, though. This is the part that really bugs me about this code. So moving on, now we're into the then clauses, right? And remember, anything that's then, this is the stuff we're actually testing. These are the things we care about, like the final state that we want to see. So this first one, output should be JSON. See, it's kind of obvious, right? But if something is screwed up to where Salt didn't give you JSON output, then the whole thing is probably screwed up, and you want to go dig into it and fix what's wrong. So that's the first thing I'm testing for, that I actually got a piece of parsed JSON out of my top step. This next one, so Salt, it's a little bit poorly named. Salt output should be a dict. Salt's, when you have the JSON outputter on, Salt's essentially always going to give you a dict. When you're running in masterless mode, okay. Well, so when you run from the master, right, it's going to give you this dictionary of output where all the keys are the names of the minions, right? Like you'll have minion A, blah, 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 minion B, blah, blah, blah. When you run masterless, it's a single dict with a single key that's called local. So that's kind of the first thing I want to do is strip that off and get to the dict that's underneath it. right? And that's where there's some variability. Now, what I found is with this particular call I'm doing, this state.showSLS, if it errors, it's going to be a list. It'll be a dictionary with the key local, and the value will be this list that has the error message. If it gets it right, it's going to be a dict. And so that's what this phase is testing, just to make sure. It's really just so this next step doesn't choke because it doesn't have the dot values function. And this final one, this is really the nail in the coffin, right? If that final dictionary has a key that's dunder SLS with a value that's equal to the state name that we were testing for, then it worked. Like, it rendered. Awesome. So, let me prove it to you. So this is that same directory I was just in. I'll show you my states real quick. So this is my awesomely complex test state. As you see, it just creates a file, nothing fancy. So we're in this directory, the directory that's the parent of the features directory, right? Remember, that's the thing that behave really cares about. Then we can just run behave, and it'll discover all the tests in that feature directory. It will then inspect all of the Python code in the steps subdirectory and figure out what functions to run and give us some nice little output. So let's do that. Hopefully. Oh, yeah. Right. Sorry, I changed some of this stuff around. Sorry, I should have tested this after I ran it all. If only I had automated testing of my test suite. Oh, that's my virtual imp. I've made a new one, yeah. Okay, fingers crossed. There we go. Okay, so this is the output we get, right? It tells us what feature we just tested, and that's just all the text that I wrote before. And it gives us the scenario text. You can suppress all this stuff if you don't want it. This is just like the straight up default way it works. And then down here at the bottom, it gives us a little summary, right? 1 feature passed, 0 failed, 0 skipped, 1 scenario passed, 0 failed, 0 skipped, 6 steps passed, 0 failed, 0 skipped. And we count 1, 2, 3, 4, 5, 6. Cool. This is a good point to mention that one of the things you can do is you can tag your tests. So you could say, like, have a set of slow tests versus fast tests. And you can control, another one is like work in progress. That's pretty handy. Like when you're working on a new state and you only care about those tests. So you don't want to run your whole suite every time. You just want to run like the 5 or 6 you actually care about. You can skip tests if something's broken for some reason and you don't want to fix it today, although you should. So handy, like dig into the Python behave docs for more information on that. Okay. So one thing that kind of sucks about this, though, right, is I typed a lot of text to just do that one little syntax test. And obviously there's going to be a better way. So we'll move on to part 2. So this is really essentially the same thing, like it's the same sort of test, but I just added a second one. Sorry. So, same feature, but now I have 2 scenarios in it. And actually, let me change this to one that's going to fail, so we can see that. Okay. So now I'm testing 2 states. This one's going to fail because it's got bad syntax. But I'm actually running the same exact tests, like literally the same code. And what I'm doing here is I'm using a feature of behave that lets us call steps from within steps. So I've got all my, oops, wrong file. On top here, this is all pretty much the same code. And then down at the bottom, I added these 2 functions. This is where the magic happens. And these are steps that are kind of meta steps. I'm just saying, hey, if you hit this step, then execute all these steps. And then I use the same natural language syntax to tell it what steps. These are all the same ones that are defined up above, right? Given I build a Docker container to validate the state. One gotcha, took me a minute to figure this out, is that you can't use the same syntax. You got to do a format, and none of the docs actually tell you that. But so if you do this, you got to format or do some sort of string substitution in here. It won't. If you put state name in there, it'll actually try to call a state called state name, which kind of sucks.
You're kind of creating a macro. Is that kind of what it's doing?
Yeah, right, exactly. So yeah, if we look back like at this feature spec, it's these 2 at the bottom are what those 2 functions represented, and it's just sort of like combining everything, right? When I run salt call state show SLS test in a container, then salt should produce a valid SLS dict for test. And the when part is basically these 3 steps, and the then part is these 3 steps. Right? So here, let me split the screen, just so everybody believes me. See? Same stuff. Line for line. Boom. Boom. Right? So this is a handy thing. Again, I really wish I had done more to get the full parameterization done. I apologize about that. I just did not have time. So let's run this one, and we'll watch one fail. Because remember, I guess I'll show you what bad test looks like. So who sees the syntax error?
Colon on line 1.
Yep. Exactly. And actually, funny enough, we had one today. It was this like exact thing. Like somebody just forgot a colon on the end, and it took like 5 minutes, 10 minutes to track down, figure out what was going on. And it's because we don't have the sort of automated testing yet. This is the real benefit of this sort of thing, right? I mean, people weren't jumping up with their hands up, so I assume a lot of you didn't see it right away. And when you're like coding all day, it can.
I only saw it because my cache was one for that issue.
Yeah, right. But when I run the test suite, boom, got our failure, right? So A, we know something's wrong, first and foremost. That's like handy. B, we know right where it's wrong in the bad test state, right? C, we know that it was a syntax. It was this test that failed. right? And then we get the nice, again, since we're running a single state, not a high state, that's part of what caused us some problems when we had this issue today. It was on a high state, right? So there's a bunch of crap. It was, 200 states ran or something like that, and we had this really kind of obscure, all we got out of it, I think, was like a YAML render error. It was something pretty minimal. And it took a little bit of guesswork and figuring out where that render error was, going back through the Git logs, doing some diffs between commits, right? But when we're testing a single state at a time, then it zooms right in on it, right? We know it's bad test. It gives us the more verbose error message. It's not hidden in a bunch of other crap. It's not like some complicated error, right? It's not, like if we had an error that was a result of something relying on this state, we wouldn't want to be confused and think it was the top level state, right? Like we test them independently. So that, I did not know that would do that. Yeah, anyways, here's a good example of what the bad output looks like. And when you get a fail, another handy feature is it will capture some more of the logging. This stuff isn't really super useful because this is just like some Docker stuff that we were ignoring previously, but it's handy in other instances. So it's something to kind of keep in mind. It's nice, to get this extra debug info. And down at the bottom, you can see this is the one that just had the 2 lines that was calling the same code, but it's using a valid syntax in the state file, and it worked. And then we, again, have our nice summary, right? We have failed feature, because this was all, remember, encapsulated in one feature. So we had no features passed. That whole file failed. But one of the 2 scenarios in that file did pass. So 1 scenario passed, 1 failed. And then we had 6 steps passed, 1 failed, 1 skipped. The one that skipped is because this failed a little higher up the chain, so it didn't do the last one.
That's awesome. Yeah.
Okay, so yeah, this is good. This is like a good first step, right? We got some useful stuff here. But it becomes hard, like when I want to test the actual behaviors of a state, right? It sucks to go through that Docker layer. And you saw on, like if you look at the step implementation file, there's all this crap about parsing the container output, right? And then there's still this potential for an error where it didn't really parse the JSON. And the more complex the output you're pushing out of Docker and then importing into these step functions, the more of a pain in the ass that's going to be. So what I decided to do is introduce another layer of testing, right? And I was talking about this, the first part here, where you have your tests that run on your host, and then you have tests that actually run in the container. Again, I like this style, so I'm using the same thing. I basically just have 2 sets of tests now. So that's what we're going to look at next. So, part 3. So, one thing, I changed up my Docker file a little bit for this. Okay? I want to make sure that I've got pip installed so that I can then install the packages I need, behave, and then PyHamcrest is like, that's the assertion library I'm using. Behave doesn't actually have an assertion library. Like, so if you want to do the assert equals blah, 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 you either got to use PyUnit or nose. I like PyHamcrest, is really cool. So that's why I'm using that one. I added a couple volumes here, right? So now I've got a volume for tests and a volume for test reports. I also changed up the entry point script a little bit, but this could all be one single script, right? Like there's no real reason, like I just made it differently so that so it wouldn't confuse the issue in the earlier ones. But so now I've got this function test state, right? And it's actually going to run behave with a couple of flags. Basically, I'm going to get JUnit style output, which is kind of the lowest common denominator of text output, like all your continuous integration tools should be able to understand JUnit. It's XML is what it is. And then I'm telling it to output these JUnit files into this serve test reports. And if you remember, that was one of my volumes, one of my new volumes I created. So now when you call this entry point script with the command test state and the parameter like a state name that you care about, then it's just going to go to this directory, the test directory, and find a subdirectory for that state. And then it's going to run behave. So you can have as many subtests as you want for each state, right? And again, we're keeping it isolated. That's why there's a subdirectory there. It's because I'm only going to want to run tests for a single state at one time. Behave will go discover tests, so I don't want to go through and find everything. Okay, so let's look first. This is what's running on the host here, my laptop. Probably could have come up with a better feature definition, but my feature is that the state, my state, works, right? It's going to run a bunch of other subtests. The scenario I'm defining, all tests defined for this state, my state, should be successful, right? So when I run the tests for the state, then all the tests should pass. Easy. Like this is, again, this is just the thing controlling everything, right? My step definition, you can see it's a lot simpler because all I really need to do is fire up my Docker container, right? And you can see that I'm passing it the command test state and then the name of the state that I want to test. It does a lot less. It's not even parsing any of the output, right? It just starts the container, runs this stuff, stops it, and deletes it. And then this function, all this one's going to do is look in that volume directory I created, test reports, right? And it's going to find the XML file that's the JUnit output for the test set for the state that we instructed it to run on. You get a lot more complex here. Like you could actually parse the XML and do all kinds of fancy stuff and make like really good output. I didn't, for my purposes right now, again, proof of concept stuff, all I wanted to make sure is that that XML output contains this string. Test suite, errors equal 0, failures equal 0. Because if that's true, then I know all of my tests worked, no matter how many there were. So next, let's take a look at the tests we're going to put onto the container. Oh, that doesn't need to be there. Oh, one other thing that I did differently on this one is in my before feature run function, I told it to go in and delete all the previous test reports. That's something to remember. But, okay, so now in this test directory, this is the stuff that I'm actually going to push over to the container. And I made a subdirectory for the state that we care about, my state. And then it has subdirectories that are just, again, this same behave mandated layout, right? Features directory, which contains all the features files, and then a steps directory, which contains the Python code. So, again, I just did the real simple one. Apologies, I went camping this weekend. I probably should have stayed home and coded, but had to get out. But I think this should prove the point, right? So what I'm doing here, well, let's take a look at the state. So again, it's the same sort of thing. Right, I'm just creating this file. And all my test is going to do is make sure that that file actually got created. Right? So if you actually think about, like, how would you do this through that Docker output? Right? Like, there's lots of ways you could do it. You could just say ls, root slash mystate.txt, but then you're going to have to, like, just parse for it in your big output string, and there's lots of ways that could get screwed up, right? Like, you can see it where it gives you an error message that has the same path string in it. So, like, for my money, I really want some legitimate Python code to run that test. And this is kind of the whole motivation for why I have this 2-layered test set up. So if this code runs on the Docker container, then I can use Python's OS library, right? OS path is file. So I'm absolutely sure that, like, that's a file that I get true back, something I can really work with, right? Like, there's no ambiguity in it. This function runs. If it's successful, it gives me back true. If it's not, so if I don't get true back from this os.path.is file, then the test's going to fail. Like, there's no parsing here anymore, right? Like, so when we get to more complex functionality, this is the way to go. Like, you really want the test to be running close to where everything's executing. And again, here you can see I'm not even, like, using the Salt command line anymore, right? I'm using the Salt Python client. Give myself a little Salt client caller object. And then I just call the state.sls function directly, right? So this is an equivalent of saying salt call state.sls state name on the bash prompt, but no bash involved. If I cared, I could parse that output directly, and I'm going to get, like, actual JSON, right? Or actually, it's not even that. It's a Python dict. And you use this. So it's already ready to go. No extra libraries, no parsing. It's great. That's the way to do it. So again, just to be verbose about it, we want to make sure that the mystate state creates a file, root/mystate.txt. So when I apply the state, then a file should exist. And again, think parameterization, right? Like, I've defined that function that applies the state. You could use that for any state now. It doesn't have to be limited to this mystate one, because again, we have the parameter, state name. This will run any state that we have defined. And the other nice thing is Behave will go and search through all your Python files in this directory, right? Like, it uses these tags, these decorator things. So as long as you have this text the same, it'll find this. And this is part of, right when I first started talking about this, how I was saying that I think one of the big fails with behavior-driven development was that they intended this stuff to be written by business users, and in practice, it really didn't work out for people. That's why, is because the business users could never, like, use the consistent terminology across the board, because they're not programmers. They didn't get it, that it's like, no, it has to be the same because of the code lookup, right? And, like, so people were constantly going back and forth, like, no, you can't have that comma here. And I think it's part of why BDD is not as well loved as it should be. Like, I think if you have a really limited glossary of terms that you're applying, this becomes real easy, right? Like, if as a coder, this is easy stuff to write because you're, again, used to using very specific keywords. The benefit is that you can define it and it's documented, right? Like, no comment string in here. I apply the state. It's pretty clear what that's doing. So let's run this stuff. Again, same thing. We just type behave. And what this did was it built up a Docker container. Hopefully you believe me about that this is actually running Docker containers.
How can we be sure?
Well, the problem, they fire up and die so fast, I could have like done something. Or I have to just like watch. I'm just like, yeah.
Sleep 1000 at the end of the shell script.
Yeah, totally. But now if we go into this test reports directory, I guess this is, I can kind of prove it. So yeah, let's delete this. Okay, so test reports is empty, right? All right, run behave. Go back to test reports, and there's my test report. And this is what the JUnit syntax is. You can see up here at the top, this is that string I was searching for, right? As long as this contained the XML, whatever it is, contains this test suite errors equal 0 and failures equal 0, it's considered a pass. Again, you could get real fancy, right? You could do stuff like, if the test runs in more than 2 seconds, it's a fail. And you know, one place where I envision going with this, like what I'd like to do is have the test runner that's running on my host run like a bunch of these tests, right? And then get all of this JUnit output and then sort of concatenate it all together and aggregate it into one singular JUnit output, which I can then display in TeamCity really cleanly, right? Or Jenkins, what have you, right? Whatever your CI framework is. So, I mean, that's kind of my long-term goal with it, is to get everything in one place. So you can run tests on all your states, run independent tests for each state. Again, I kept it simple, but there's a lot. I hope, hopefully you can imagine some of the things you could do with this, right? Like we could have that, we could look for a particular host name in that file. We could do it dynamically based on grain values or pillar values. We could run this simultaneously on a Ubuntu box and a CentOS box, or more relevant to what we're doing at Upsite, a CentOS 6 box and a CentOS 7 box, and then compare the output and say this output has to be the same. If it's not the same, then fail, right? So lots of complex things we can do in this sort of realm. But yeah, that's what I have for today. Like I said, I'm continuing working on this, so next time I will have probably some minor improvements to this code. And then I want to talk about the next level, which is testing using vagrant boxes or virtual machines in general. Because one of the problems with Docker containers is it's not, they aren't full VMs. And in particular, things like services are a little bit not the same. So if you want to test services interacting, I start to think that vagrant boxes might be the way to go. I'm probably still going to play around a little bit and see if it's worthwhile, like getting, like, say, Upstart running on a Docker container and see how that works. But if you remember in my slides from last time, I was talking about the sort of 3 levels of testing, where you have unit testing, integration testing, and acceptance testing. So this stuff all kind of represents the unit tests to me. It's a little bit of a metaphor, but it's these little small pieces, like we're testing the syntax of the files, and then we're testing that they do these minimal things that they should be doing. At the next level up, we want to test how states interact with each other. That's sort of the integration level, right? So we might want to have more complicated tests that are doing, like, maybe I have a state that installs an actual web app. So I want to make sure that it gets the web server, and then it sets all the SSL certificates properly, and then it starts the, application code. And then the final level, at least as far as I'm concerned, is sort of acceptance testing. And I see that as relating to, like, okay, make sure the port is open. Make sure that the web app is actually serving content that we expect. It's not going to be as detailed as if you were like writing a test suite for your web app, but it would give you a lot of surety that your states are operating properly, right? If you run through each of these levels, it's like, okay, I got all the syntax, cool. Okay, I got all the interactions and the high level, compound state stuff working, cool. And then now I know, and at the acceptance level, I know that my infrastructure is actually doing what it's supposed to be doing. And again, I picture putting performance tests in there too, where it's like, how long did this all take? To keep with the analogy, how fast is that web app returning data, right? And then, like, the cool thing you can start doing is iterating and making stuff faster in a provable way, right? Like, I'm of the opinion Nginx is faster than Apache, but I've never actually tested that, right? And like, what if you did? Like, what if you started looking at things like, hey, how does this configuration change that I make over here actually going to impact my performance on my infrastructure? How's it actually impacting my resource usage? Right? These are cool things to know, and I don't think like enough people are asking those sorts of questions. Like, that's where we go from here. So, anyways, questions, thoughts? Feel free to discuss. Thank you.
Yeah, maybe before the questions, thank you to Upsite, Jason, Wendell over there. Thank you so much. And Upsite team, thanks for having us here. We appreciate it.
It's our pleasure. So, I don't know, is this stuff interesting? Is this more stuff we want to keep?
Just comments on that, Jason. So what you're talking about here, there are people talking about it and asking about it. And in my opinion, it's the most progressive companies that are asking about this stuff. It's the guys that you saw at Salt Conference. They're big, huge, at-scale companies that it's a pain for them. Like,
Yeah.
When something hits the fan, they need some type of automation to fix. So we're having these conversations. It's interesting to actually see. This is not concepts right now. This is like coded stuff. So this is really cool stuff to see.
Basically in like 1 month's time too.
Yeah.
The last meeting, he's like, yeah, I kind of think I might do this, and I'm sure you've put some good thought into it, but it's pretty impressive to see how you've gone from last month's meeting to this month's meeting.
Oh yeah, I did this on Sunday, like after I got back from camping.
Did it afternoon on Sunday after camping. No, I think some of the largest companies are. I think they are. I mean, you can chime in here, Mark. It's standard. They're push out a deployment. I run through all my tests, and those tests and all the barriers that they have to finally put into production, even for these most agile big companies, it's painful, it's costly, it takes too much time, too many resources. Some of the companies that we're talking with, it's a 4.5 every month from right after work, 6 p.m. till 6 a.m. And they're trying to find ways of like when something breaks, that team then triage. They're diving in, and then they're manually rebuilding stuff. So to see this, especially within a Docker container, which that's some of the feedback we're hearing now is like we love Docker or we love containers in general, but how do I keep control over all these things that are spinning up?
Right, that's another thing. I was kind of thinking, I wanted this to be really clear what was going on. I didn't want to muddy the waters with using a bunch of Salt built-ins. But I kind of was thinking that if this would be like a pretty cool thing to do with Salt. Right? It's already got the Docker container management built in. Again, you've got that awesome like messaging system, right? So I could actually send my test results back and forth across the message bus and not have to worry about like mounting volumes and all that crap.
That's next month.
Are you on the latest, Jason?
I just started playing with it. We're not using it in prod yet.
Just to kind of add to what Keith said, just kind of provide a little bit of context, additional to what Keith was saying. So we have customers that, like they said, they do a release every month. And pre-salt, it was literally 6 at night till 5 or 6 in the morning. And then salt took it to the next level, and they would be able to go from 6 at night to maybe midnight or 11. But a lot of the time in preparation for that, to bring in that, was testing their states, making sure that the syntax was correct, that the output was correct. And so what the Upside's done is kind of taken it the next level. Is they're reducing, not only are they reducing the salt, reduce the time to implement, to put in the code in production, but this kind of testing would reduce the preparation time for those monthly events.
Right.
Because they're manually, in the customers that we're thinking of, I don't believe they're doing any of these kind of testing, and so this is fantastic stuff that you guys are getting from Upside. So.
Yeah, I mean, I want to integrate this into I want this to be part of our continuous integration stuff. Like, we already have, like, all of our states and all of our pillar changes are in version control, but it's a kind of a manual code review process right now. And we have a lot of engineers who write states, which is nice. I mean, I'm not complaining about that. It's awesome to have the engineering team write their own states and get better at this sort of stuff. But, they do break stuff a little more because they're not domain experts in this sort of thing. And that's where I would really like it where somebody puts a commit into our salt state repo. It runs all the tests, makes sure nothing broke. We know that it worked last time there was a commit. If you just committed something and a test didn't work, your fault. We can reject that commit, say go fix it, and put it through again.
Or even, we could even have a report back to the pull request and require an acceptance
Right.
of these tests before the pull request is even eligible for merge.
Right, exactly.
We do with all of our code, but probably the most important repository in our infrastructure, we don't do that with. So I think this kind of enables this repository to come up with the same standards we hold all of our code to. That's great. I haven't seen this before.